Hello friends, welcome to my channel. This is Isro question paper 2006 to 2016 Strength of Metal part 2. The question is, for a body subjected to direct stresses sigma x, sigma y and sigma z, the direct strain epsilon x in x direction is dash E given and your gamma Poisson's ratio and Young's modulus given. I usually take mu is Poisson's ratio here. So this is important for all examination. In GATE also this question is asking. For sigma x, epsilon x, strain in x direction minus mu into sigma y by E minus mu into sigma z by E. One by E you take common, sigma x minus here gamma they took, gamma into sigma y plus sigma z. From option B is the answer. Here one more thing is important. Strain in y direction. For volumetric strain, mu into sigma x by E, mu into sigma z by E. In z direction, strain is sigma z by E minus mu into x by E minus mu into y by E. For volumetric strain, sigma x, epsilon y, strain in x and y and z direction. Put the values, what we will get. Mu into sigma y by E minus mu into z by E plus mu into sigma x by E minus mu into z by E plus third one epsilon z by E minus mu into sigma x by E mu into y by E. If you take common 1 by E, sigma x plus sigma y plus sigma z minus 2 mu sigma x plus sigma y plus z 1 by E. Take sigma x, sigma y and sigma z common. 1 by E into, take common, it's 1 minus 2 mu. This is very important formula. Volumetric strain is to sigma x plus sigma y. In conventional papers also sometimes they are asking, they will give some values, you have to find the volumetric strain. In thin cylinder question also sometimes they are asking, you have to use this formula. IES, GATE, Isro, all examination, this is very important. A circular shaft subjected to torsion undergoes a twist 1 degree in a length of 120 cm if the maximum shear stress induced is limited to 1000 kg per centimeter square and if modulus of rigidity G equal to 0.8 into 10 to the power 6 kg per centimeter square, then the radius of the shaft should be, know that formula, J equal to tau S by R G theta by L. Here theta given as 1 degree, convert it into radian, 180 degree pi radian, 1 degree pi by 180 radian. Then length also given 120 cm. Maximum shear stress induced tau S 1000 kg per centimeter square. Modulus of rigidity G also given 0.8 into 10 to the power 6 kg per. No unit conversion required because all are in cm or centimeter square. So from formula, if you take R equal to tau S into L by G theta, tau S 1000, L 120 divided by G, how much? 0.8 or 8 by 10, 10 to the power 6, theta in radian, pi by 180, 0.8 you make it as 8 by 10. For better calculation you can do it. 10 to the power 6, 6 zeros, 3 plus 1, 4, 5, 6 zeros cancelled. Then here 8, 4 into 3, 4 into 2, 2, 18, 9. And how much it will come? 27 by pi centimeter. Answer is D. This formula is very important. This one, and for bending. Both are very important for all exams. Whatever the exams, irrespective of examination, both are very important. So you should remember both. A hollow shaft of same cross-section area as solid shaft transmits same cross-section area. This is the key word. If same cross-section area, then hollow shaft will transmit more torque than the solid shaft. If space is constant, then hollow shaft will transmit less torque. Both are important. Constant or restricted. Then solid shaft will transmit more torque. But in this question, cross section area is same. So hollow shaft will transmit more torque. Cross section area, or sometimes they are telling weight. Weight is the constant. Both are important. I will explain you. In this question, area is same. This is hollow shaft. Sorry, this is solid shaft. Its diameter is D. Hollow shaft, inside diameter DI and outside diameter DO. K you take DI by DO. For easy calculation we are taking K. Here what given? Same cross section area. So area of solid equal to area of hollow. You take pi by 4 d square equal to pi by 4 pi by 4 cancel, d square equal, take do square common, 1 minus k square, k is di by du. So d by du equal to 1 minus k square whatever. Then your power transmission, P solid by P hollow, T into angular velocity omega, T into omega, both are same. So Ts by Th. Torque solid, for solid set torque transmission pi by 16 tau s dq. For hollow shaft, from that formula, T by J tau s by R. If you put J equal to pi by 32 du to the power 4 di to the power 4, R equal to du by 2. If you put for hollow shaft, this is for hollow, J for hollow, T equal to tau s into JH by R equal to tau s into pi by 32 du you take common, 1 minus k to the power 4 by du by 2. If you solve it, you will finally get pi by 16 tau s into du q 1 minus k to the power 4. So finally we will get P solid by P hollow equal to T solid by T hollow torque pi by 16 tau s dq cancelled, dq by in IES conventional papers they will ask this one. This is equation 2 and earlier this is equation 1. Both value if you take from equation and equation 2, whole q 1 minus k to the power 4. Finally we will get root over by 1 plus k square, which is less than 1. So pH is greater than PS or TH is greater than TS when weight is constant. or area is constant. Area is same. Cross-sectional area. Or when space is constant, then Ts is greater than Th. This is very, very important. Both 5-star. Next question. The extension of a mild steel bar 4 meter long, 2000 mm square cross section under the action of an axial load of 20 kilonewton if E equal to Young's modulus equal to 2 into 10 to the power 5 Newton per mm square is dash. Data given L equal to 4 meter, 4 into 10 to the power 3 mm. A equal to 2000 mm square. Load P equal to 20 into 20 kilonewton. Newton. E equal to 2 into 10 to the power 5 Newton per mm square or MPa. Megapascal. So extension. We know PL by A. Put the value 20 into 10 to the power 3 into L 4 into 10 to the power 3 divided by 2000 10 to the power 5. So 5033 6 plus 7 5 plus 2 7 2 cancelled 5 1 by 5 mm 0.2 mm. From option B is the answer. In I section, shear load is resisted mainly by A. Flanges only, B. web only, C. both flanges and web, D. none. I section. This is flange part, web. This is flange part. Here shear stress distribution. Shear stress distribution. This is parabolic, then straight line, then parabolic, again straight line from here to here, parabolic. Parabolic here, parabolic, here also parabolic. Shear stress distribution. From that figure you can imagine very less portion taken by flange, maximum portion in web. So its answer is web. And one more thing is important. Shear stress distribution. Web bears most shear stress. One more thing is important here. Flange bears most bending stress. Both are important. If in this question I section bending resisted mainly by, then their answer will flange for bending. B is for shear load. Next question. Shear force is a rate of change of loading, B sum of bending moment, C rate of change of bending moment, D none of the above. Shear force. dm by dx is shear force, and d shear force by dx is load. M is bending moment, load. So shear force is rate of change of bending moment. C is the answer. Maximum shear stress in Mohr circle is equal to. This is also important for all exams. GATE also this question was asked. Maximum shear stress is this one. Radius of circle. If a material expands freely due to heating, it will develop. This question was asked so many times in IAS and GATE also this question was asked. So this is very, very important. Expands freely. This is the keyword. Due to heating, it will develop zero stress, free expansion. When column is fixed at both ends, corresponding Euler's critical load is column. Euler's critical load. That formula is P shear critical load is pi square E. I is minimum EI by effective length square. Both 4 I will give you. All four conditions are important. Fixed free, load is acting, all four are important. Fixed condition, then here one side fixed, other side hinge, fixed and hinge. And finally both side hinge. Load acting, load acting, load acting. Curvature, how it will become, I'll tell you. In this case, fixed and free. Effective length is LE equal to 2L from here to here. In case of fixed, it will become like this. So L by 2. And in case of fixed and hinge, it will become L by root 2 effective length. Here it won't change. In this case, effective length LE equal to L. It remains same. Condition of hinge and hinge, both side hinge. LE equal to 2L for fixed free, for fixed L by 2, for fixed and hinge effective length is L by root 2, and for hinge effective length is L. So this is, in this question, fixed at both ends. This is the second one, fixed at both ends. Put the value LE equal to L by 2, will get 4 pi square EI by L square. So from option D is the answer. Next question. A metal pipe of 1 meter diameter contains a fluid having a pressure of 10 kgf per centimeter square. If the permissible tensile stress in the metal is 200 kgf per centimeter square, then the thickness of metal required for making the pipe would be. It's question of thin cylinder. Thin cylinder, maximum stress is circumferential of hoop stress is formula is PD by 2T. From data, D is 1 meter. You take all are in centimeter square. You take 100 cm. Pressure 10 kg per centimeter square. Then next for removal tensile stress 200 kg per centimeter square. So sigma C equal to sigma Y equal to PD by 2T implies put the value of sigma Y 200 equal to P how much 10, D is 100, 2 into thickness T. We have to get thickness T equal to 10 into 100 by 2 into 200. 2 that's 5 by 2, 2.5 centimeter. Here options they are in mm, so you convert it to mm. Sometimes in options they will give you 2.5 mm. So for unit you should be careful. If you convert 2.5 cm to 25 mm, you will get C is the answer. Circumferential and longitudinal strength in the cylindrical boiler under internal stream pressure are sigma 1 and sigma 2 respectively. Change in the volume of the boiler cylinder for unit volume will be dash. The same question was asked 3 times in Isro. In 6 years it was asked 3 times. So this is very important. Circumferential and longitudinal strengths. So change in the volume of boiler. Change in volume. Volumetric strain is 2 times circumferential and 1 time longitudinal. Here in this question, circumferential is epsilon 1 and epsilon 2. From option, it's C is the answer. Next question. If water in closed pipe freezes, the pipe will dash. This is that same thin cylinder question. Sigma C is greater than sigma L. Circumferential stress. Stress or hoop stress. Sigma C. Here sigma L, longitudinal stress. PD by 2T. Here sigma C is greater, so it will break like this. pressure will act like this and it will break like this. So answer is D. Rupture along a line running longitudinally along the pipe. Failure along longitudinal joint. This is failure along longitudinal joint. Failure occurs due to circumferential stress or hoop stress, because that is bigger than that longitudinal stress. Thank you friends for watching my video. If you like my video, then subscribe it. Keep sharing with your friends. Thank you.